Hello everyone, this is Chandan Jha, and in this video I am going to discuss basic concepts of trigonometry for 9 and 10. Now let us consider one triangle ABC where we have considered angle C as theta. Now it is known to us that angle A plus angle B plus angle C will be 180 degree, as sum of all the angles of a triangle is 180 degree. Now in place of angle B we can write 90 degree, and in place of C, as per our consideration, we are writing theta. Thus, we shall get angle A is equals to 90 minus theta. So we can write this. So we get, if this is theta, then this angle will be 90 minus theta. So always remember, in a right angle triangle, other than this 90 degree, the rest two angles are always complementary to each other. Next, let us discuss the ratios one by one. So first of all, sine theta. Sine theta is defined as the ratio of perpendicular or opposite to its hypotenuse. So hypotenuse is the longest side of the right angle triangle, and sine theta is the ratio of perpendicular or opposite to the hypotenuse. So in this triangle, if we consider this as theta, then sine of angle C will be opposite by hypotenuse, that is AB by hypotenuse AC. Next, cos theta. Cos theta is defined as the ratio of base to the hypotenuse. So base here for this theta, base is BC and hypotenuse is AC. So similarly, base for angle A will be AB and hypotenuse will be AC. Now if we consider theta here, then cos of angle C will be BC by AC. Then cos of angle A will become AB by AC. Now let us come to the third ratio. Third ratio is tan theta, and that is defined as the ratio of sine to cos. And sine is opposite by hypotenuse, cos is base by hypotenuse. So ultimately we shall get opposite by base. So remember this part. So tan theta is sine theta by cos theta, and that is opposite by base. So for this angle C, tan of angle C will become opposite by base. So AB by BC. Similarly, tan of angle A will be BC by AB. Now, the reciprocals of these three ratios that we have discussed of sine, cos and tan. So reciprocal of sine theta. So reciprocal of sine theta is cosec theta. So cosec theta is equals to 1 by sine theta, reciprocal of sine theta, and therefore it will become hypotenuse by perpendicular or opposite, as sine theta was opposite by hypotenuse. So cosec theta will become hypotenuse by perpendicular or opposite. So thus in this triangle, cosec of angle C can be written as hypotenuse, that is AC, by opposite AB. Similarly, cosec of angle A can be written as AC by BC. Now, the second reciprocal, the reciprocal of cos. So 1 by cos theta, that is sec theta. So sec theta is defined as the reciprocal of cos theta, and ultimately the ratio will become hypotenuse by base, as cos theta is base by hypotenuse. So therefore sec theta is equals to 1 by cos theta, and that is equals to hypotenuse by base. So for this triangle, for angle C, we can write hypotenuse by base, AC by BC. Similarly, sec of angle A can be written as AC by AB, as for angle A, base is AB. Now the third reciprocal is reciprocal of tan. So 1 by tan theta, that is cot theta. So cot theta is 1 by tan theta, that is cos theta by sin theta, as tan theta is sin theta by cos theta, and ultimately base by opposite, because it is opposite by base. So reciprocal of tan will become base by opposite. So in context of this triangle, cot of angle C will be base by opposite. So base is BC, opposite is AB. Similarly, cot of angle A would be AB by BC. Now let us understand by one example. We have considered a triangle PQR here, and considered PQ as 8 cm, QR as 6 cm. since it follows Pythagoras theorem being one right angle triangle. So 8 square plus 6 square is equals to PR square. So we can check here, 8 square is 64, QR square is 36, that is 64 plus 36, 100, and PR square, 10 square, 100. So it is verified. Now in context of this triangle, let us consider the ratios one by one. So sine of angle R, and here it is sine, that is opposite by hypotenuse. So for angle R, opposite is PQ, and hypotenuse is not going to change, so it is PR. So 8 by 10, and the ratio is 4 by 5. Similarly, sine of angle P will be opposite, that is 6 by PR, hypotenuse, and 3 by 5. We can observe here that sine of angle R we are getting 4 by 5. Sine of angle P we are getting 3 by 5. That means here it is a ratio. So that doesn't mean that the length of opposite and the length of hypotenuse will be exactly 4 and 5 units respectively. It is a ratio. Yes, the length of opposite and length of hypotenuse will be the multiple of 4 and 5. But their lengths will not become 4 and 5. As we can see here, the actual length is 8 centimeter, actual length of hypotenuse is 10 centimeter, but the ratio is 4 by 5. So this sine or cos or tan, all this trigonometrical ratio indicates the ratio, not the exact length of the corresponding sides. Next is tan of angle R. So tan of angle R, that is opposite by base, PQ by QR, so 8 by 6, and after simplifying we shall get 4 by 3. So here also we can see it is a ratio 4 by 3, not the exact length of opposite and base. Therefore, it is 4 by 3. Next, tan of angle P. Tan of angle P can be written as 6 by 8 opposite by base, so ultimately 3 by 4. Next, if we consider cos of angle R, cos of angle R will become base by hypotenuse, that is 6 by 10, and after simplification it's 3 by 5. Cos of angle P, here base is PQ, that's 8 centimeter, by hypotenuse 10 centimeter. Now let us do one more example. Question is, if tan of angle A is 5 by 12 of a right angle triangle ABC and right angled at B. So tan of angle A is 5 by 12 of a right angle triangle ABC, right angled at B. Then find sine of angle C. Our task is to find sine of angle C. So for finding out sine of angle C, we require opposite by hypotenuse. So the length of hypotenuse is required for this ratio. So how to do this question? So first of all, let us focus on the given condition. Tan of angle A is equals to 5 by 12. Tan means opposite by base. So tan of angle A in context of this triangle is opposite BC by base AB. So BC by AB is equals to 5 by 12. And just now we have discussed that these are ratio. It indicates the ratio of the sides but not the actual length of the sides. So therefore we need to consider a constant because BC is multiple of 5 and AB is multiple of 12. So therefore let us consider a constant K. So let K be any constant such that BC, because BC by AB is 5 by 12, so such that BC is 5K and AB is 12K, where we have considered K as a constant. Because this is BC by AB, it is a ratio, not the exact length of BC and AB. So therefore this consideration of constant is very important. Now since it is a right angle triangle, so therefore it will definitely follow Pythagoras theorem. So by applying Pythagoras theorem, hypotenuse square is equals to perpendicular square plus base square. So that is AC square is equals to AB square plus BC square. And after putting the values, we shall get AC square in place of AB, that is 12k square, 144k square, BC square, that is 25k square, ultimately 169k square, and AC will be square root of this, that is 13k. Now we can find out the ratio of sine of angle C. Now sine of angle C here is AB, because here we have considered angle C. So opposite AB by hypotenuse AC. So sine of angle C is equals to AB by AC, that is 12k by 13k, and ultimately the ratio is 12 by 13. Thank you for watching.